How to reduce eddy currents in the transformer core? Actually, we have two methods here. The first one is by selecting the core material. Here we can select as iron or steel as the core material, but we are preferring silicon steel. First let me discuss why among iron and steel, why do we prefer steel. We prefer steel because we have high permeability of steel compared to iron. Why do we need a high permeability? Because the core has to permit the flux, so we require high permeability. So among iron and steel, we prefer steel because it has high permeability. And next, why do we go for silicon steel as the material? Because steel has two qualities: high permeability, and it also has high conductivity. High conductivity means it conducts more current. So we don't want eddy current, so we don't want high conductivity, we don't want the current through pass. So we prefer high permeability but not high conductivity. So to reduce the conductivity of the steel, we add silicon to it. So we add 4 to 5% of silicon to steel. Why we add this much percentage is because it reduces the conductivity, but it keeps the permeability as same. But it reduces the conductivity nature, thus by reducing the eddy currents. So by adding 4 to 5% of silicon steel, we get a perfect material for core. Why not we add 10% or 20%? Why don't we add is because if we add 10% or 20%, by adding silicon to steel, it adds brittleness. Brittleness is like it adds the delicateness, and it's tend to break. The core will be tending to breaking nature. So we don't prefer this much. We only prefer 4 to 5%. Okay, this is the first one. Why do we select only silicon steel as the core material? And the second one is, why do we prefer laminations? Why don't we use a solid core like this? Why do we prefer laminations like this? It is because we know resistance R is equal to rho L by A, where rho is resistivity, L is the length, and A is the area. So by keeping rho and L as constants, if we decrease the area, that is, if instead of using a solid core, if we use laminations, area will be decreased. And if we decrease the laminations, then the resistance will be increased. What happens if the resistance increases? Actually, by Ohm's law, we know V is equal to I into R. At a constant voltage, I will be inversely proportional to R. If we increase the resistance, then the current will be decreased. So if we increase the resistance of this core by placing the laminations, then the eddy currents which will flow there will be decreased. So we prefer the laminations. So how do we separate these laminations? Actually, the laminations can be we'll discuss 2 points about laminations. Thickness of laminations. Actually, 0.35 mm is the thickness of laminations which will be mentioned in any textbook, but practically the laminations will be 0.25 mm. The thickness of laminations. In textbook it will be 0.35, but in practical it will be 0.25 mm. So these are the laminations. Between one lamination and another lamination, we will be using an insulator, that is, which separates one lamination from another one. So insulation means it do not allow the flow of the current. So what are the types of insulations which can be used between two laminations? There can be a varnish coating, it can be a china clay, or a paper that is a normal paper which is dipped in the oil. It acts as a good insulator. So they also can be kept between these two laminations. So this is the overall summary how to reduce the eddy current losses. Thank you.